Hello, hello. We are back with Chapter 10, Probability, Lesson 5, Making Predictions, and this is the guided practice. So, making a prediction based on an experimental probability, that's what we're going to be working on. So, number 1 states a bowler knocked down at least 6 pins 70% of the time. Okay, there's that percentage for us. Out of 200 rolls, how many can the bowler predict will knock down at least 6 pins? So we have this percentage, so we need to go ahead and make sure we convert that percentage to a fraction. And 70% is the same thing as 70 over 100, okay? So we're going to go 70 over 100 is equal to, we are going to roll it 200 times, and we want to know how many times are we going to knock down at least 6 pins. So, boom, there we go. We're going to solve for x. That means we need to get x by itself. Right now it's being divided by 200, so we need to do the inverse operation of division, which would be multiplication of 200 to both sides. Those 200s cancel. We're multiplying fractions, so we have to look to cross cancel first. Is there a common factor between 100 and 200? The answer is yes, 100. 100 goes into 100 one time, 100 goes into 200 two times, and then we just multiply across. So we're going to go 70 times 2. 2 times 0, 0. 2 times 7 is 14. So that ends up being 140. Okay, so that means the bowler will knock down at least 6 pins 140 times out of 200. All right, perfect. Okay, so now it is your turn. I want you to try problems 2, 3, and 4 on your own. Here's our friend, the pause dragon, reminding you to pause your device. Go ahead and work those problems out. When you finish, press play, and we'll talk about them. All right, we're back. Let's see how you did. Number 2 says a tennis player hits a serve that cannot be returned 45% of the time. Out of 300 serves, how many can the tennis player predict will not be returned? Okay, so a tennis player hits a serve that cannot be returned 45% of the time. Out of 300 serves, how many can the tennis player predict will not be returned? Okay, so we have our percentage right there, 45%. So we're going to make that into a fraction. 45% is the same thing as 45 over 100. Okay, the total number of serves that we're going to have is going to be 300, and we need to figure out how many of those serves are not going to be returned. So we just need to solve for x. We need to get x by itself once again. Right now it's being divided by 300, so we have to do the inverse operation of division, which would be multiplication of 300 by both sides. We're going to go ahead and do that. These 300s cancel. We're left with x. Woohoo! And then we just need to go ahead and multiply this fraction. First, we look to cross cancel. There is a common factor of 100. 100 goes into 100 one time. 100 goes into 300 3 times. And then we multiply across. I'm not sure what 45 times 3 is, so I'm going to go off to the side and do that really quickly. 3 times 5 is 15. Carry the 1. 3 times 4 is 12. Plus 1 is 13. So it ends up being 135. So boom, if you got that right, awesome job. Okay, let's move on to problem 3. So problem 3 states, West Palm Beach, Florida gets rain about 16% of the time. On how many days out of 400 can residents of West Palm Beach predict they will see rain? Well, here we have our percentage right here. So we're going to go ahead and change that percentage into a fraction. 16% is the same thing as 16 over 100. We're going to set that equal to how many days are we talking about? We're talking about 400 days. That goes on the bottom, and we want to know how many days out of 400 it's going to rain. We don't know that, so we put an x. Okay, we're trying to solve x and get it by itself. In order to do that, we need to get rid of the 400. 400 is related to x through the division, so we need to do the inverse operation of division, which would be multiplying both sides by 400. Those are going to cancel. What do we have here? We have 100 and 400. The common factor is 100. 100 goes into 100 one time. 100 goes into 400 4 times. And then we're just going to multiply across. 16 times 4. So 4 times 6 is 24. Write the 4, carry the 2. 4 times 1 is 4, plus 2 is 6. So that ends up being 64 equals x. Okay, so they will see rain 64 days out of 400. So if you got that one right, awesome, awesome, awesome. Okay, on to problem 4. This states that Rob notices that 55% of the people leaving the supermarket choose plastic bags instead of paper bags. Out of 600 people, how many can Rob predict will carry plastic bags? Okay, so 55%, we're going to change that into a fraction, 55 out of 100. And that's going to equal, now we're looking at a total of 600 people. And we want to know how many of those people will carry plastic. So, again, we need to isolate x, get it by itself. We have to do the inverse operation of division, which would be multiplication of 600 to both sides. The 600s are going to go ahead and cancel each other out and become 1. We've now isolated x. And we're going to cross cancel here. Is there any common factors between 100 and 600? Yes, 100. 100 goes into 100 one time, and 100 goes into 600 6 times. Now we're just going to multiply across. 55 times 6. I'm going to take that off to the side to do really quick. 55 times 6. 5 times 6 is 30. Write the 0, carry the 3. 6 times 5 is 30 plus 3 is 33. So, yeah, 330. That would be the amount of people out of 600 who would carry plastic bags. All right, let's go ahead and move on to the next page. So for these problems, we're going to be making a prediction based on theoretical probability. Okay, let's look at problem 5. Problem 5 says, Martin flips a fair coin 64 times. How many times can he expect the coin to come up tails? So we have a fair coin. A coin has heads and it has tails, right? So with a coin, you have 2 options. I'm going to make a little tree diagram here. You have heads or you have tails. So there's 2 outcomes, but we want tails. That is the desired outcome, okay? So there is 1 desired outcome out of a total of 2 outcomes. And then we want to know how many times are we going to come up with tails if we flip it 64 times. So we put x on top. Now we just need to go ahead and isolate x and get x by itself once again. So we need to get rid of the 64. The 64 is related to x through division. So we're going to do the inverse operation of division, which would be multiplication. We're multiplying both sides of the equation by 64. Okay, we have x by itself because all that cancels out and becomes 1. 1 times x is x. Then we look to cross cancel over here. So 2 and 64, is there a common factor? Yes, there is. 2. 2 goes into 2 one time. 2 goes into 64. I'm not entirely sure, so I'm just going to go ahead and do the division really quick. 2 goes into 6 3 times. 3 times 2 is 6, and that's 0. We drop that 4 down. 2 goes into 4 2 times. 2 times 2 is 4, and then boom. So 2 goes into 64 32 times. And then we just multiply across. 32 times 1 is 32. 1 times 1 is 1. So x equals 32, which means we can expect to flip a tail 32 times out of a total of 64 times. All right, now it is your turn, ladies and gentlemen. I want you to try 6, 7, and 8 on your own. So there's our pause dragon reminding us to pause our device. When you get done, go ahead and press play, and we'll talk about your answers. Okay, we're back. Let's go ahead and see how you did. 6, it says a spinner has 5 equal sections labeled 1 through 5. In 60 spins, how often can you expect to spin a 3? So we have, what is this? A spinner, right? We have a spinner. And the spinner has 5 options. 1, 2, 3, 4, and 5. Okay, so that's a total of 5 outcomes. Now, we want to know how often can we spin a 3. That is our desired outcome. So there is 1 desired outcome out of a total of 1, 2, 3, 4, 5. And we want to know how many times are we going to spin a 3 if we spin it a total of 60 times. And so we don't know how many times it's going to happen out of 60, so that's why we put the x there. And now it is time to solve x and get it by itself. Well, right now, x is being divided by 60, so we need to do the inverse operation of division, which would be multiplication of 60 to both sides. These 60s cancel out, become 1. 1 times x is x. And then we have 60, we have to look to, we're multiplying fractions, so we have to look to cross cancel. Is there a common factor between 5 and 60? Yes, there is. I'm pretty sure 5 goes in there, but I'm not sure how many times. So I'm going to go off to the side.